Hello colleagues, my name is Alexander Zelenin. I'm software engineer with more than 15 years of experience. Today we will try to solve Google Online assessments with JavaScript. So we have up to 2 questions and we will have limit of 1 hour. We will need to solve fast as possible and with minimum attempts possible again. So we will try to understand the problem, find the ways how to solve it, design an algorithm, write code, test it, and then submit. So let's start. Let's see what we have here. You are giving a license k represented as string s, which consists only alphanumeric characters and dashes. The string separated up to into n plus 1 groups by n dashes. Given a number k, we would want to reformat the string such that each group consists exactly k characters, except for the first group, which could shorter than k, but still must contain at least one character. Furthermore, there must be a dash inserted between two groups, and all lowercase letters should be converted to uppercase. Okay, sounds like a combination of couple problems. Let's try to understand them one by one. Given a non-empty string s and number k, format the string according to the rules described above. So it looks like we just removing all dashes, and then we start to creating a string, and that's all. Right? Okay. Originally it doesn't sound complicated at all. So generally it's about removing dash and insert proper amount of symbols. Like few problems here, that if we want to do this with one move, it will be hard to do by reason that we cannot calculate how many symbols we need to put in first group, by reason of we don't know how many dashes we have. So I think we can start with I don't know, maybe constructing an array, or not an array. Let me think. Okay, a string can be split in 3 parts, each one up to 2 characters. Let's see what we have in note here. The length of strings not exceeds 12 thousandths of characters, and k is positive integer, so it's minimum 1. String consists only alphanumeric characters. Okay, but we need to ignore only dashes, so it's not a big deal. Okay. The thing that we possibly want to avoid is to construct string for every symbol, because in JavaScript it's a costly operation, but for interview it's not a big problem, because like it can be optimized later on. So okay, let's start what we have here. So we will need to first remove all dashes. We will do this with just replace function. And then we will construct new string, and that's all. So s replace dash with nothing. Okay, and then replace with nothing. Then we have s length as amount of symbols, and we will need to count math floor of this. It will be a count of groups, so const count groups count, and first group size will be what is left from this. So first group size will be as length. So what is left from dividing? So for example, if it's 10 and we have 3, then we will get 1 here, and that's fine. And we also need to make it uppercase. So let's do it at the same moment. So 2 uppercase. Done. Okay, so we have group counts, we have first group. We will constructing the result string. We can do this by creating an array. So const result will be an empty array, and we will return result join with the dashes. Okay. So first we'll see if first group is greater than 0. So if first group greater than 0, because if it's 0, we don't need to create the first group, like all of them will be same size as here. So if first group greater than 0, then we push result push, sorry, and we pushing here as a substring from 0 up to first group length, so like this. And after this we making a cycle. We will start from the first group size. We will do this until I is less than s length, and increase I by 1. Okay, I can do like this. We increase I by 1, and we will do the same with so we have k as size, and we need to provide I here, and I will be not +1 but like current step multiplied by so I think we need to replace it with while then, or have 2 counters, right? So I want to start with the numbers like 1, 2, 3, 4, 5. So we have group counts. Generally, yeah, we can start with like from now we will need to skip the first group size, then we will go up to groups count from the first one, from 0, 1. Yep, from 0, 1. We go up to groups count, and here we will have something like first group plus I multiplied to k. So if we have 9 symbols, for example, we will have first symbol, so we will skip the first group size, which is 1. And initially it's 0, so we will start with first symbol and we will take 3 symbols. Then on second iteration we'll have 1, 1, 2, 3, 3 plus 1, so we'll start with the fourth symbol, right? So let's run and see what we'll have here. Maybe there will be that's strange. So it looks like exactly that we calculate something not properly. So okay, let's see what we have here. So we have 4 symbols. Let me print s here. So console log s. Just want to be sure. So looks like, yeah, it not remove the symbol itself. It make the string uppercase, but by some reason this symbol is not removed. Let me just take a look one more time. What is the problem? Why only some of them? Very strange. So it looks like by some reason not all of dashes are replaced. So generally speaking, it replaces only the first one. But replace function should replace all of them. I need to take a look at this, because I was sure that it replaced not only first symbol. Can I switch to English, please? Return new strings with all of them replaced. So what is the problem? So initially we have dog 2 times, but it replaced it only once. Okay, I was not right. Replace do it 1 time. So we need to use regex in this case. Fine. My mistake. For the regex, we will have we don't need to have something like this, so we'll have something like that, I presume. So this will mean that we will search globally, so for all symbols in this case. Yep, and this looks fine. Oh, it's good that we tested. I for a long time had not to use replace. Maybe not sure. Okay, so right now our answer looks properly. We had not submitted yet, it's just test results. So let's see what we have with another input that was provided here also by test. So like this. So looks like proper answer as for me. What if we will have multiple dashes here? It will not change anything, right? Right. No, to change something. No. Everything is the same. Everything is fine. Even if we will start with anything here, there will be no difference. What if we have exactly like 1, 2, 3, 4 dash like this? Okay, fine. What if we don't have any dashes? Fine. So okay, let's try to submit our code and see. Yep, success, everything fine. So first task is done. Let's go to next question and see what we'll have here. Suppose we abstract our file system by a string in the following manner. So it's again about strings. The string looks like a path to some file, represents directory. Okay, it's a new line. Subdir, file. Okay. The directory dir contains an empty subdirectory subdir1 and subdirectory subdir2 containing the file. The string. So with the symbol t, we the count of symbols t represents the depth. So the directory dir contains the string represents the structure. Okay. The directory dir contains two subdirectories. This one contains file, empty second level subdirectory. This one. Okay. We're interested in finding the longest by number of characters absolute path to a file within our file system. For example, in the second example above, the longest absolute path will be this one, and the length is 32, not including the double quotes. Okay. Giving a string representing the file system in above format, return the length of the longest absolute path. The name of a file contains at least one dot and an extension. Name of subdirectory will not contain a dot. Time complexity required O(n), where n is the size of input string. Okay, it's the task itself doesn't sound complicated, but we need to design it properly. First of all, we will create something like a tree. Okay, so we'll have one directory, we'll have subdirectories. These subdirectories will have files and so on. And we will try to find all the... So to create this tree, we will need to go through every... to go through string, to split it by n's, then count how many t's we have before every element, and this splitting will took O(n), so going through string, then generating tree will take O(n), so it's still under O(n), and to find the longest path, we will go from bottom to top. I don't remember how this algorithm calls, but for example, if you have 3, 5, 7 and 3 symbols here, and also we have some count of symbols here. For example, let it be 5, let it be 6, and the initial directory also is, for example, 3 symbols. So we take a look at all subdirectories we have. We see the size of them, and take we need the largest one, right? So we will ignore this one and we'll increase here, so we'll have 10 here. Then we will do the same operation on the right side. So we will compare both of them, and we will took 7 here, so we'll have 13. And here we perform the same operation and take 13 here, and in the end we will have 16, so we'll ignore this 10. Okay, so first step, generate tree. Second step, go through this tree to find the solution. Okay. So what will be our tree format? First of all, in this tree, it's not binary tree. We will able to have a lot of successors. I hope I use proper word. Not sure how it will be represented yet, but fine. Let's start with this. So names. We will split it by /n. I want to just return 1 for now, and print names to ensure that I do everything fine. And yep, so we'll need to count how many t we have at start, and replace them. So originally we can just replace t and find the difference between the start size and final size, and it will exactly represent the depth that we need to go. And like, if depth is lower, then we go 1 level up. If the depth is increasing, then we go inside subdirectory. But we cannot go inside the file. In this case, I will presume that the structure provided is proper one and will not test that like the string itself do not contain an error. Usually it's not required in such type of tasks. So, okay. We need to go through names. Let me use cycle for now. Don't want to use for each because I feel that there will be some additional modifications later on. While I is less than names length, we increase I. Current name will be equal to names I replace, and this time we will don't make this mistake. So we need to replace every symbol. We need to replace symbol T. We make symbol T, G. What is wrong here? Yep. And the name it will be replaced with nothing. And we will have depth equal to the length of this one and minus name length and divided by 2. We even don't need to make a floor since we remove every time only by 2 symbols. So I want to have console log here, name depth. So let's just take a look at what we have. So we have looks like by some reason it not represented properly. Looks like yeah. So tab symbol is counts like as one symbol. So because it's like tab symbol. So we can like ignore dividing. And yet, yes, right now we have the proper like leveling at least. So now we need to create a tree and I'm just thinking how to do this better. So let's create an additional method. This method will be for creating the node. So function create tree node, and it will get value, some value, and it will return an object. This object will have first of all value, but generally we don't need to string to store the string itself, right? We need only to store the length of the string. It doesn't perform any operations by finding path or anything like that. No, we need to print we need to print number, or what we need to print? Yeah, we need to print only number, so the name itself doesn't matter for us anything. So instead of storing value, we can have length that will be value length. Okay, and we'll have also question here. Do we need to find the... Yep, that is very important thing originally. We need to have some kind of flag that it have files inside. Otherwise, we don't need to count it, alright? Because in this case, it told, and the task itself is to find a file. Containing a file. We're interested in finding the longest absolute path to a file. So it's super important to let's create like this. Is file. It will be value index of dot. If it not equal to -1, then it means that it is file. And here we will first of all, in this cycle we'll take a look how depth change every step, and we will apply something like have files. So have files. Initially it will be false, and if like in in the OR algorithms, if we, for example, will have files равно false, equal false, fall back to native language. Then we will not count this and we will go with 3. Okay? And when we will go step like on the upper level, then we will just thinking. So we will just ignore the nodes that is not file and doesn't have file, so that's fine. So what we have here, we have node, we have maybe let's store parent. Let's provide it, and we will have children, which will be an empty array initially, and we will put something inside of this if it's not file. So generally we have 2 types of something here, is files and directories, so that's fine, I think. So let's create a tree. I'm just thinking how to do it better with like. Okay, I knew how to do this. If depth is 0, so we have changing of depth, okay? If the depth is same, then we have additional items on same level. If the depth is decreasing, then we closing directory. If depth is increasing, then it means that we move something inside, like we create additional children and put something inside these children. So, and every time we will put everything to the last children. So we have like 30 minutes and we should able to do this in time. The important thing is to create proper tree and to test it. So maybe let's create also count. I just want to return count at start. So we have depth, previous depth equals 0. So we have name, we have new depth, and we need to take a look is it was increased or decreased. So if depth equal to previous depth, then we perform insert. If the new depth is greater than previous one, then we go inside and insert. If it not greater and not equal, so it's lower, then we find a difference between them, like previous depth minus current one, and we go up for this amount, this count. I just want to add a few strings to be able to scroll. So okay, we have these operations here, and we need to start with implementing them. So what we will have in tree? Let me think. Is an object is a good thing? What about? I mean, the object as node is good, but what about the root one? Do we want to have something like a name here? I think it will be fine to store them by names, right? Or maybe also to store them as an array initially. So, okay, yeah, let me maybe create a tree node initially, yep, instead of this one. And the value will be empty one, like no value, so we will have zero length. It will be not a file, and it doesn't have files. It doesn't have a parent, and it will have a children. So we create our initial node. So let it called head, and let have a node head like this. Current node will be equal to head initially, and maybe it's reasonable to have initial depth like -1. So we start with -1, so it will be increasing to 0. So now we need to insert the first child, right? So, okay, we're starting with 0 for now, and then we will debug. So if we have 0, if we have same depth, then we do something like this. Node children, okay, push create new node, and we provide here two things. We provide name, and we provide node itself as a parent, just to have back reference. I'm not sure will we need this one or not, but it will be easier to have it. So we push children, fine. Then if our depth is greater, then we do something like this. So it can be greater only by one level, right? We cannot go up to 2 levels same time, because it's like meaningless. So we have node, we have so we will go to the last children. Children will have length -1. We go to last one, so just make node equal node children, fine. We had to go inside of the last one, and now we can perform insert of our new one. Looks like good. And here we need to have some additional variable, how many levels we need to go back. For example, we were on 4th level, and we have the 1st level. So we need to go like 3 levels back. So levels back, let me call it exactly like this. Don't want to spend too much time on this. So we'll have like for let k equal levels back, while k is greater than 0, k minus 1. And we will have like node equal node parent. Right? We have parent, so we can go back to this level. Okay. And we also perform operation like push. So we perform push operation in in any case. So we can put it in the end, and we can change our condition, like we do this only if depth is lower than previous depth. And we can remove the first condition like this. So we just go inside, go outside, and perform push. And after this, we save current depth as previous one. Okay. So at this moment, I presume we have something like a tree. Let's take a look. So console log head. Maybe there will be some errors, but at least we should have something. So we have parent undefined, which is fine. Maybe let's have not undefined, I want to have it like null. Like it more explicit that it doesn't exist. Like it's not undefined, it's not exist. So we have like this, and also when we go to upper level, I want to have something like has files. So when we go to previous ones, I want to have something like has files equal to false. And when we perform okay, let's create additional one and call it current. No, I cannot do this because yeah, right. Okay, I don't need a current one. So what I want to do here, no, I need current one, and I want to have it here. How to call it better? Let's call it current, and put here current. So if current we have is file, if current is file, then we make has file true, has files true, and we will remove it after we go like to upper level, or when we So if we go inside of directory or create any additional one, so we'll have something like has files false, and when we go inside, This inside one doesn't guarantee to have any additional files. Maybe it's redundant a bit, I'm not sure, but we have just 15 minutes left, not too much. But enough to solve this problem. So when we go back on every level, we need to mark node has files, node have files to true. And we go up to highest one, and we also will make it to have files true. Okay. When we go inside, we doesn't mark anything like has files. When we go in the same directory, we also doesn't mark anything as files. Also, I think when we go upwards, we also need to take a look at okay, let me start with this. I feel that I have an error here, but I'm not sure which one exactly. Yes, but it doesn't work properly. So we have files true, have file false, because we need to perform going to the top level, like at the end. So we will repeat this operation until the topest level. We have target depth as 0. We will go to 0. We will make have files equal to last option of has files, but it's not the proper one. Yeah, and also this one is not guaranteed to have files. We need to check the node itself. So if node have files, like we marking only current node to have files. So node have files equal to has files. When we go to upper levels, we also apply the same rule. Like this. And in the end, we mark that we doesn't have files, and that's fine. So we check that the current node has files will be equal to node have files. So for every level back, we perform the same operation as it was before. So like this. have file false. Oh, what is the problem here? The problem also that I doesn't see the all trace. Doesn't like such things. Okay. Let's think quickly what we can do here. So let's go through our tree quickly. So let's make a debug function. We will take a tree and we will try to print everything here that is required. So we do console log, let have also depth 0. Let's print tree length. Tree is file and tree have file is file. Tree has files. And also we will add something like minus repeat depth. After this we make something like not tree here, but okay, it doesn't matter. Tree children for each. For every children we'll call the same function. We will provide the child itself and depth +1. Okay, so let's use our debug function to see what we originally have here. So by some reason the second argument is undefined. So we have true for is file, right? For zero false undefined. 0 false undefined. So we have has files, and the reason of this, of course, because I have files and not has files. So let's rename all of them to this one and see what we'll have here. So now we have false, 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 and on the last level we have true. So then it means that we have a problem on this one. Maybe when we inserting node, we can check that. Yeah, let's do exactly like this. So if current one is file, if current parent also exists, current parent also exists, then current parent have files will be equal to true. Okay. True. Okay, nice. We have tree. We have just a few minutes left. And we need to go through like every node and choose the largest one. So function get max depth, 3, max length. We providing a node here. We will go through. So we have 3 length. First of all, we check that if tree is a file or tree has files. If it has files or it file itself, we return length of itself. So first of all, if it's file, we return instantly the length of itself. So tree length, we call it length, right? All right. So we return length. If it have files, then we will return itself length. So tree length plus we need to go through every of them. So function get max children's. So let max length equal to 0, return max length. We go through children's for each, and we are looking for child get max length of the child. So const cur length, if cur length is greater than max length, so max length is equal to cur length. So we finding the max children of 3 children and current length. I'm not sure what we got after this originally. So let's take a look quickly. We need to find get max children of head children. So what we need to get here, we have age 7, so 15, 18, right? So get max children, max length 0, we go through all children's. We are going to get to max length. If it has files, we return itself, and we provide all children's. We go through all children, try to get max length. Max length will be equal to length itself. I just want to take a look what we have here. So by some reason we have nothing here. Think fast what we need to do. We go through every single, let me zoom out. We go through every single children. We provide head age, true, false, max children, go through head children's. For every of these children we try to find the largest value. The value of it will be equal to itself plus the maximum size of okay, I am not on time, so let me just copy this. It happens sometimes, so it happens sometimes. Time is up. Nothing was submitted. Okay. But I want to solve it to the end, since I feel that we are very close. So we failed this attempt. The reason for this because we doesn't return anything here, and we need to return 0. So why we return 0? Because the root doesn't have files, right? No, it has files. So what we're printing here is length of tree, that it have file, that is file and have file. So the root is fine here. Let's see what we have here. So we are taking the length of current node, and we are taking the max children. Why I cannot change size of console? It's very stupid as for me. But okay. So let's see. Const max children length. I just want to see the max children length at every step. So we have only numbers here. Maybe it will be reasonable to still save names, just for debugging purposes. So let's write console log here. Console log. We'll have tree name and max children length and length of itself. So tree length. I'm not sure that it have something inside, because we doesn't have output at all at this moment, right? Why? Okay. what we have in children's. Let's see. So children's is an array. That's fine. Every item is a node. For node we have function get max length. Right. So let's have a look what we have here. So I will remove console logging children's. We'll see what we have here. So we have a node like deer, length 3. So what is the problem? Have files true. Oh my god, that's all. I again make this mistake. Have files has files. Really? Seriously? And we have 18. My god. So right now I had failed test just because I'm bad in English. That's all. So just because I have name the property with wrong name. I use wrong name for property. And like some times ago I make this mistake, and now I make this mistake one more time. So, and that's the only mistake I had make here. Like otherwise we will be in time to solve all of this. Yep. So let me remove all console logs. But expected is still calculated not properly. Let's see what we have here and try to understand like what is still wrong. So we should expect 20, and why it will be 20? So we have longest path here, right? So we have 8. But like I have 18. Why I should have 20 here? One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. What I had missed? Okay. I miss that for every level we also adding additional symbol. So but I think that this problem will be also solved on time if I will not make this mistake with have has. Like why I name it has one additional time. Okay, let's finalize our code and submit. At least I want to submit it without errors. Like we had not submitted, we just make a test runs. So we'll have something like +1 here. Yep, so let's submit our code. Yep, so we solve everything properly. Every single thing was proper one, except I had name variable one more time has files. Okay, one of all other requirements here was to have complexity of on. Let's see what complexity we have here. Okay, so first of all, like in worst case, every single line will be new, so we have on for splitting. Creating node is O1, so it's 1. Going through all names we have is on, but only if nothing inside here is like special one. And we calculating amount of tabs here, which also like a part of the string itself. So it's not like multiplied with each other, like both of them will give on, since we still not parse more than this amount of symbols. This is 1, like this is 1. Going levels back is still limited by the depth. Like we can go only one level inside on each level, and for example, if we go 10 levels inside and 10 level back, even we have a cycle here, it still counts as on, since it's just increase like x2. It's same thing like with arrays. When you push new elements, and array increase itself size 2 times. So we have still on like in these combinations, since all the algorithm have this logic that it will not happen often. So it's just increased by 2 times. We create node which is 1. We push which is 1. So we have on here. Fine. We go back again. It doesn't count. It's like 1 here because it's like constant depending on what how many times we had to go inside. For getting max length, we have a recursion here of 2 functions: get max length and get max children. First of all, we go through all children's, and for every children we go through itself. If it's file, we return length. If not, we go inside one more time and make with these cycles with each other. Generally speaking, we will visit every node just once. We don't visit nodes more than once. So we visit the count of nodes by n. So every node visited just once. We doesn't have any additional logics or loops here. Like we have this loop, but we visit every child just once. And every child of child again just once. So we have on here. So generally we have on as it was required initially. And for memory consumption, for every file or every node we store this structure. So we also have on. We don't store anything additional, any big substructure and so on, even they are inside of each other. So the algorithm was proper one. The approach was proper one, it was designed properly and so on. So I hope at least it was fun and like you learned something. If so, set like, subscribe, and have a nice day.